My name is Russell Manser, and this summer I worked at Unidata on robust data type testing and Dask support in MetPy. So the big idea here is that Dask support in MetPy will enable users to distribute calculations across large meteorological data sets. So for those of you unfamiliar with MetPy, it's a Python package for meteorological calculations and plotting. It's designed and developed for community use by the geosciences community, and it's dependent upon the scientific computing stack in Python. So some of the libraries that it's dependent on include NumPy, Xarray, and Pint. And these libraries are either array-like data structures and operations, or they in Pint's case, it includes physical quantities, so you can attach quantities to these arrays and then operate on them, and the unit conversions take care of themselves. So some of the examples of things you can do in MetPy are shown here. We have an 850 millibar temperature map from a forecast model, and then an observed SKU-T sounding. Both of these are from the Python gallery for MetPy. And then Dask, on the other hand, is an array-like library. So it's kind of like NumPy, except it's designed for larger than memory or distributed memory calculations. So since it's like NumPy, it has a lot of the same API as NumPy. Some of it's reduced, though, because there's challenges with distributing certain calculations across multiple compute nodes on a supercomputer. And so Dask is part of the scientific computing stack in Python, and it tries to integrate itself cleanly with these other libraries. And shown here is a depiction of a Dask array, which is composed of multiple NumPy arrays, which are these purplish boxes. So all of these NumPy arrays together collectively form a Dask array. So then the idea here was to integrate Dask into MetPy because as MetPy's user base has grown, more users are requesting newer features. And one of those features was the use of Dask for distributed calculations. So this will help users make efficient calculations on large data sets, such as climate observations and simulations, forecast ensembles, and also high-resolution cloud model output. So with this idea came along the idea of systematic data type testing, since integrating Dask arrays into MetPy would introduce a new data type. There was already an open issue for testing data types, so might as well bring these two ideas together and just create a whole suite for testing all of the data types that are supported by MetPy. So then the objectives are to integrate Dask support in upstream libraries. There were a few things that needed to be done in order for MetPy's dependencies to fully support Dask, which then in turn MetPy can support Dask. And then design automated data type tests, and finally identify functions that need special handling or refactoring for full Dask support in MetPy. Some of the challenges that came along with this started with the typecasting hierarchy in the scientific computing stack. So there's all of these data types that are array-like that are trying to work together, and they either need to be aware of each other or need to wrap each other in a way that doesn't interfere with calculations that are assumed to be available to each of those data types. And then, as I mentioned with Dask, there's many operations and calculations that can't be performed in a distributed way. So some road bumps that were encountered while trying to get some MetPy functions working with Dask included some of those operations. So there's going to be refactoring needed there. And then MetPy needs to remain accessible for community use and contributions. So Dask is a pretty advanced library, and we need to make sure that when we're putting Dask into MetPy, that we're not making anything in MetPy any more complicated than it needs to be already. And also, when introducing this data type testing suite, we want users to be able to add to the data that's available for new functions. So if a user wants to add a new function, we want to make that easy for them to test it in this suite. So then I'll move on to talking about integrating Dask in these upstream libraries and MetPy. So the big challenge here is the order in which data types are wrapped, the typecasting hierarchy, and how those wrap types behave, or duck typing, is crucial for expected behavior of each of these types. In other words, if it walks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck, and we expect it to act like a duck when we're operating on it. So the three main libraries that I worked with to try to get Dask to play nicely in the upstream libraries were Xarray, Pint, and Dask. So Xarray needs to be aware that Pint can wrap Dask arrays, and then I needed to implement some code in Pint so that Pint could wrap Dask arrays. And so I've done that latter portion. I've implemented Dask and Pint. You can see that pull request on GitHub. And I'm currently in the process of creating support for duck Dask arrays in Xarray. That just required a few changes to some lines where it was checking for Dask array types. And then this leads nicely into Dask array tests in MetPy and the data type testing suite. So MetPy generally supports data types that are common to the scientific computing stack, but not all of the functions in MetPy explicitly test against each of these individual data types. So the idea here is that we're going to explicitly test all functions against all data types, and I also created a framework so that testing for new data types could be easily implemented. So MetPy currently supports types such as scalars, not a number values, NumPy arrays and masked arrays, and Xarray variables and data arrays. And going back to that idea of users adding a function to MetPy and being able to test it in this suite, I've got an example here of what that might look like. So sorry, I can't zoom in a whole lot more than that, but I'll try to explain it. So dictionaries are a pretty common type in Python, and here we have a nested dictionary. So all the test data is stored in this larger dictionary, and then each of the nested dictionaries pertains to a single function. So in this case, we have the wind speed function. So that's the name of the function, which is the name of the nested dictionary. And then the arguments for that function are u and v for the wind components. So those will go into the function, and then the output of that function will be tested against the speed value here, which is the truth. So the idea is that a user can easily add a function name and some argument values and a truth value to automatically test their new function against all of the supported data types in MetPy. So then some future work that still needs to be done is implementing the proposed framework across all of the calc modules in MetPy. I only wrote this up for one of the modules just as a kind of prototype of what this might look like. I'd like to have some further discussion before I fully flesh this out to all of the other modules. And then I still need to address some challenges for Dask support in MetPy pertaining to individual functions. So like I said, there might need to be some refactoring or special handling for Dask arrays. And with that, I will take questions.
Hey, Russell.
Hey.
I love the poster.
Thanks.
And really great presentation of it. I was just curious what sort of changes you had to make with Pint, what these you said you've implemented Dask and Pint. I was just wondering what sort of steps you had to take to accomplish that.
Yeah, so Dask actually has documentation on how to implement their library into your library. So they call it the Dask collection interface. So it's this group of functions that you just implement into your library, into a class. And by implementing those functions, Dask is aware that your class is now a Dask array or Dask quantity of some sorts. And so, yeah, I had to implement that collection interface and then make sure that obviously it tested nicely and everything in Pint.
Cool. Thanks.
Yeah.
I have a quick question. Does Dask work directly with NumPy arrays then? Like, did you not have to do any implementation for that, or do they not work together?
So NumPy is like way at the bottom of the scientific computing stack, and so all of these other array-like libraries build off of it. So I didn't do anything directly with NumPy, but instead Dask, what Dask is doing is saying that it's got this collection of separate NumPy arrays that it's operating on, and that's a Dask array.
So like Xarray and Pint are built on top of NumPy, and then Dask is built on top of that?
Yeah, Xarray and Dask are built off of NumPy, and then Pint tries to integrate itself nicely with these other array libraries.
Gotcha.
It's actually a little more complicated because Xarray can hold data that's either stored in NumPy or stored in a Dask array.
Yeah.
So it's either or. So that's where it gets complicated, as you have
Nice.
a variety of options.
Yeah.
But it's turtles all the way down, and Russell's done a lot here to help smooth the way. Everyone, like a lot of the community has already done Xarray and Dask. We're the odd ducks out because we use Pint, which also can wrap things. And so trying to insert another wrapper in amongst this hierarchy is where the challenge has been. And so that's what Russell's done a lot of work this summer to help smooth over.
Cool.
Russell, could this be applied to other packages besides the MetPy Xarray combination?
How do you mean?
Basically, what you've got is a mechanism for testing type cross function, if I understand this correctly. And the question is, could it be applied to other APIs, basically, where you want to test all the types against various functions in the API?
Possibly, yeah. Yeah, I don't see why it wouldn't be able to be ported to other applications. I don't know if I have generalized it enough such that it would be able to do that right now, but I think I could see that being done.
Okay.
To be clear, it's using Python stuff though, right? So other Python projects, right?
Yeah, other Python projects.
Or
yeah,
things
like,
wrapped in Python.
So you meaning like wrapping C++ or Fortran or things like that?
I think NetCDF, frankly.
NetCDF. I don't know about like NetCDF Python objects. I mean, I would assume it would be able to handle that, but personally, I use Xarray to handle NetCDF stuff. So I think that's a better solution than trying to implement support for NetCDF objects. Did that answer your question? Is that what you were getting at?
Yeah, Xarray is actually a subset, so it's certainly simpler to do than the full NetCDF API.
Okay.
Or a larger subset. But okay.
Anyone else with questions for Russell?
Nice presentation, Russell. Quick question. Have you done any performance benchmarks?
I didn't get that far.
Okay.
That was something I wanted to do, but I got kind of wrapped up into the X-array stuff and trying to help them sort out the duck Dask arrays in there. But yeah, that's something that I think should be done once we get to the point of Dask getting into MetPy, just to make sure that there isn't any loss in performance.